So here they say to us two blocks having masses of 10 kg and 4 kg are connected together by means of a light inextensible string, and they are placed on a horizontal surface. When a force of 58 newtons is applied to the 10 kg block at an angle of 25 degrees with the horizontal, the system accelerates at 2.72 meters per second squared to the right, as we can see in this diagram. The 4 kg block experiences a constant frictional force of 2.5 newtons. Okay, that's fine. Now, let's analyze this a little bit, all right? Here we can see that we have a string that is connecting the two blocks. So if we have a string, a rope, a cable connecting two blocks, then we know that we are dealing with a tension force. And according to Newton's third law, the 10 kg block is going to pull the 4 kg block to the right. In other words, it exerts a tension force of a certain magnitude on the 4 kg block to the right, okay? The 4 kg block is going to retaliate by exerting an equal tension force, but it has to go in the opposite direction, which is to the left. Okay. Another thing we know is that if two blocks are connected together by a string, a rope, a cable, or anything, they are going to move at the same acceleration, which is why here they say the system accelerates at 2.72. It means the 4 kg block is having the same acceleration as the 10 kg block of magnitude 2.72. So both of them, they claim that acceleration because it's rightfully theirs. Okay. Now, furthermore, they tell us that the 4 kg block is going to experience a frictional force, a kinetic frictional force, which means the surface is rough. If the 4 kg block is experiencing frictional force, then it stands to reason that the 10 kg block has to experience frictional force as well. We are also given the magnitude of the applied force that is exerted on the 10 kg block, and we see that it's a force that is applied at an angle. So in other words, it's a two-dimensional force. And we know that we can never work with a two-dimensional force. We must always resolve that force into its horizontal component as well as its vertical component. All right. Now, looking at the first question, they say state Newton's second law. Well, of course, that one I know you can definitely destroy it, which is why we need to pass it as though we don't see it. Now, next they say draw a free body diagram showing all the forces acting on the 10 kg block. All right. And this is for 5 marks. And one thing we know about a free body diagram is the mark allocation is directly proportional to the number of forces that you must show, right? 5 marks, 5 forces that you must show. But on your rough work section, you also need to draw a free body diagram showing the forces that are acting on the 2 kg, in fact, the 4 kg block as well. Okay. Well, I thought I gave this whiteboard a title. I'm not sure what happened to the title. Yeah, I'm not really sure what happened, but I think it makes a lot of sense for us to give it a title, right? So let's call it Newton's second law of motion. But if we just say Newton's second law, then it's perfectly fine. There has to be a title, otherwise, what's the point? Okay. So now let's go to this 4 kg block, all right? Well, we know that it's actually not the one that is being asked, but we know that we have to draw the free body diagram for it as well, so that we can see the forces that are acting on it as well. Now, the first force is going to be the normal force, which is exerted by the surface, and it's always perpendicular to the surface. Then we also have a force that is equal to the normal force, but it's acting in the opposite direction. And that is the gravitational force. And I want you to know that the normal force is not always equal to the gravitational force. They are only equal in this case because there is no other force that is acting at an angle. If there is a force acting at an angle, the magnitudes will be completely different. You'll also see how different the free body diagram for the 10 kg block will be. Then we also know that we have a jealous force, which always opposes the success of a certain object, and this is the kinetic frictional force. And of course, we have the tension force because the 10 kg block is pulling this 4 kg block to the right. And even though we don't know the magnitudes of the forces as yet, but we have to see that the tension force has to be greater than the frictional force. Now, how do we know the tension is greater than the frictional? Because the net force is going to the right, because the acceleration is going to the right. Okay? Okay, that's fine. Now let's move. Then we come and draw the free body diagram showing all the forces acting on the relevant block, which is the 10 kg one. Well, once again, we have the normal force, but in this case, the normal force is going to be less than the gravitational force. Now the question is, why is the normal force less than the gravitational force? Well, it's because this force, which is applied at an angle, it is actually going to have a vertical component. And if you take the normal force, you add it to the vertical component of the applied force, then you're going to get the gravitational force. All right? Yeah. So you'll come and say, well, this is the normal force and this is the gravitational force, the most consistent force in the universe. And here we have the applied force. And of course, we do have a jealous force once again, which is the kinetic frictional force. But then it's not only the kinetic frictional force, we also have the tension force, which of course is going to the left because the 4 kg block is pulling this 10 kg block towards itself. So this is how the free body diagrams of the two objects are supposed to look like. Now that we know how the free body diagrams are supposed to look like, then they say calculate the tension in the string which is connecting the two blocks. And this is for 4 marks. Well, it's not really bad in this case. Why? Because we are given the acceleration of the system. Under normal circumstances, we are not given the acceleration. And in order to find the tension, we normally find the acceleration first by using simultaneous equations. And now that we have our acceleration, then we can substitute it into any of the equations in order to find the tension. But in this case, they already gave us the acceleration of the system. So we just need to choose any of these two blocks. Well, we don't really choose any. We choose a block which we are given the most information about. And in this case, it's going to be the 4 kg block. Why do we say it's the 4 kg block? Well, it's because if we look at the horizontal forces, We know the magnitude of the kinetic frictional force. We also know the magnitude of what? Yeah. Yeah, no, we know the magnitude of the kinetic frictional force, but we don't know the tension. Or it's only two forces that are horizontal on the 4 kg block. So we only have one unknown and we know the acceleration. So it becomes easy. But if you look at the 10 kg block, you don't know what is the magnitude of the tension force number one, and that's what you're looking for. You also don't know what is the magnitude of the kinetic frictional force. It's not given to us. We are also not given the coefficient of kinetic friction. So there's no way for us to find the kinetic frictional force, all right? Okay, so that's the conclusion. We are just going to use the 4 kg block in order to find Aibo. Seems like Zoom has changed because each time I leave the whiteboard, it erases everything. Look now, the free body diagrams are gone. And the title is also gone. No, this is bad. Really bad. But let's not give it a title again. We already assigned one. So let's move. So here we need to find the tension. So we specify and tell them that we focus on the 4 kg block. Then what are we going to say? Well, we are simply going to apply Newton's second law. So how do we apply Newton's second law? We tell them that the resultant of the forces is equal to the product of the mass times the acceleration, okay? But now here we can see that we only have two horizontal forces, and we always take the direction of motion as positive. In other words, right, we take it as positive. You can also take it as negative. It's perfectly fine, but it's a matter of preference to make things easier. So in other words, the tension force is going to be positive and the kinetic frictional force will be negative. Okay. Okay. We don't know what is the magnitude of the tension, but the kinetic frictional force is given to us as 2.5 newtons. The mass of this block is 4 kilograms. It is experiencing a constant acceleration of 2.72 meters per second squared. So in order for us to find the tension, we just take this 2.5 to the right and it becomes positive, all right? So in other words, we have 2.5 plus 4 into 2.72. And we find that the magnitude of the tension in the spring will be 13.38 newtons. And if you said this, the marker is going to be so happy that he gives you all the marks. The next one says, calculate the coefficient of kinetic friction between the surface and the 10 kg block. Okay, now this one is a major problem. In order for us to calculate the coefficient of kinetic friction, that's if we know the normal force and also if we know the kinetic frictional force. Because we know that, yeah, what do we know anyway? We know that the coefficient of kinetic friction, or maybe it comes from this equation that says the kinetic frictional force is equal to the coefficient of kinetic friction multiplied by the normal force, all right? So we need to find the normal force and we also need to find the kinetic frictional force. Now the question is, how do we find each of these? Which one is the easiest to begin with anyway? Well, it's easy to begin by finding the kinetic frictional force, okay? Because we can simply use Newton's second law for that. So we tell them that we are now focusing on the 10 kg block. And this is how we focus on the 10 kg block. We say, okay, fine, the net force that is acting on the 10 kg block, once again, it's equal to MA. But now we have 3 horizontal forces acting on the 10 kg block, and there's only one force which is going in the direction of motion. And this is the horizontal component of the applied force, which we know that it's F in the X, right? So we have F in the X, which is added to the negative of the tension force, to the negative of the kinetic frictional force, and you say this is equal to MA. Immediately, I must warn you. The tension force, we now know its magnitude. It's 13.38. So we can definitely give it a sign. But we don't know what is the magnitude of the kinetic frictional force. If you don't know its magnitude, you never give it a sign. Okay? Never. Even though we know that it's supposed to be negative, but you're just going to say it's positive because we don't know its magnitude. Therefore, we don't give it a sign. Okay. So now we can come and say, well, in order for us to find a horizontal component of an applied force, that's if we take the applied force itself and we multiply it by the cosine of an angle. Then we say minus the magnitude of the tension force. We now know it as 13.38, but we don't know what is the kinetic frictional force. The mass of this block is 10 kg, and it's accelerating at 2.72 meters per second squared. Okay. So now we can just go to the calculator and say, what is 58 cosine 25 degrees minus 13.38? Well, let's give it a good look. We have 58 cosine 25 minus 13.38. So we simply get 39, and then you say point. So please don't round this off, ne? Just write it in full, 39.1858 5165, so that it doesn't affect your final answer, right? And then you come back and say you have 10 times 2.72. And when you do, you get 27.2. So now it's time for you to take 39 point dot to the right-hand side, and it becomes negative. So when you say 27.2 minus 39.18585165, well, you find that your kinetic frictional force, correct to 2 decimal places, will be negative 11.99 newtons. But of course, you need to conclude and say, well, therefore, it's going to be 11.99 newtons to the left. Or you can say in the opposite direction to the direction of motion. Okay, so now we know the magnitude of the kinetic frictional force. The next thing we need to do is to find the magnitude of the normal force, right? Okay. In order for us to find the magnitude of the normal force, we need to remember the free body diagram. And this is how the free body diagram looked like. We said we have our object here, and we had the normal force which was surprisingly shorter than the gravitational force. Now, the reason for that is because there is another force which is acting at an angle. Let's just focus on these three forces because now we are working with the vertical forces. Okay. If we look at this force which is applied at an angle, we know that it has a horizontal component. It also has a vertical component. So in other words, in this case, we have three forces which are vertical. It's the normal force, the gravitational force, the vertical component of the applied force. So what? Well, now we just need to come and say, how would we find the normal force? Well, by using the fact that if we take the normal force, we add it to the vertical component of the applied force, the result will give us the gravitational force. So this means the normal force is going to be the gravitational force, which is 10 times 9.8. Then we say minus the vertical component of the applied force, which is 58 times the sine of 25 degrees, all right? So let's see how much do we get when we press this into the calculator. Well, we have 10 times 9.8 minus 58 times sine 25. And we find that the magnitude of the normal force, well, since it's not the final answer anyway, we are not supposed to round off. Even the kinetic frictional force, we were not supposed to. So let's just write it in full and say, well, it's 73.488, 14082. And then we say newtons. Well, it's not the final answer, so let's go for the kinetic frictional force as well and say 27.2 minus 39.1858 and then 5165. Then we get 11.98. So we have 9858565. So that's after the comma. Okay, now we have everything that we need in order to find the coefficient. Then the next step is to state the definition of the kinetic frictional force, which is the fact that it's the coefficient of kinetic friction multiplied by the normal force. Then we can come and say the kinetic frictional force is 11.9858, 5165. And this is equal to the normal force, which is 73.488 again. And then you have 14082. Then you times this by the coefficient of kinetic friction, or you could have begun with the coefficient. That's perfectly fine. Then the last step is just to divide both sides with your normal force. So when you go to your nice calculator and plug in everything, then you find that the coefficient of kinetic friction will simply be 0.16. Let's take it to 2 decimal places. So, because it's the final answer anyway, we have the full right to convert it to 2 decimal places. And if we set this, they should be happy and award us all them. So the last one says, the angle at which the force is applied is now decreased to 15 degrees, from 25 degrees to 15 degrees. How will the answer that you calculated in question 4.3.2? In other words, how will the coefficient of kinetic friction change if the angle of the applied force is now decreased? Well, you'll tell them that the coefficient of kinetic friction will do what? That's a very good question. Because if you decrease an angle, what is going to happen is the normal force is going to increase. Okay? And if the normal force increases, then it means the kinetic frictional force will increase as well. Okay? So if the kinetic frictional force increases, then it means the coefficient of kinetic friction, it will have to increase. The answer has to be between it increases or it remains the same. So which one is going to be? But think of it. No, the coefficient the coefficient is going to remain the same, Aussie. Why? Because I remember something in the textbook. They said it depends on the type of material of which the two surfaces are composed of, right? And then what else does it depend on? It depends on two things. And since those two things are still the same in this case, then the coefficient of kinetic friction will remain the same. What is going to change is the normal force as well as the frictional force. Both of them will increase, but the coefficient of kinetic friction will remain the same. Now, let me quickly grab my textbook and explain it to you.